Okay, here we have an explosion. There's a 10 kilogram mass at rest, and I'm just depicting it with this circle. And as a result of the explosion, it kind of splits a little bit off center so that a 6.8 kilogram portion flies off to the right. So this is my after picture down below. This represents the explosion. And that 6.8 kilogram piece flies to the right at a speed or a velocity, and I'll call that V1 of 12 meters per second. Now, initially, nothing's moving. So my initial velocity of the entire system, all that 10 kilogram mass all stuck together, is 0. And the goal is, as a result of that explosion, momentum still has to be conserved. What is the final velocity of the other piece that's flying off? Now, I've taken the liberty of showing you that the other piece is 3.2 kilograms in mass because they have to add up to 10 kilograms. So 6.8 plus 3.2 makes 10 kilograms. And the question is, what is the final velocity? And I'll just go V2 for that 3.2 kilogram piece. So as usual, it's momentum before has to equal momentum after. Collisions and explosions, it's always the same setup. And we have to look at all the masses involved. But the trick to this one is, since momentum is mass times velocity, there is no momentum before. Nothing is moving before. It's a stationary object. Then there's some energy that's involved that blasts them apart, but in terms of momentum, no momentum before. Definitely have two momenta after. So we have one object moving to the right, which I'll call P1, and then we have P2 moving, we think, to the left. So now we put in our values. 0 equals M1 V1 plus M2 V2. And we're trying to figure out what V2 is. So if I rearrange the equation and solve it for V2, I get M1 V1 is equal to negative M2 V2. I simply subtracted an M2 V2 from both sides and then swap the sides. So now we go ahead and solve. We're trying to get V2 by itself. So I get V2 is M1 V1 all over negative M2, and I just put in my values. 6.8 kilograms times 12 meters per second, and I said that was to the right, so I'm going to watch my signs, positive 12, all divided by negative 3.2 kilograms. And when I do that, I get a value that's negative 25.5 meters per second. And we interpret this negative as it's moving in the opposite direction. So with significant figures, 26 meters per second in the opposite direction.